Welcome back to bilingual e-lectures for diploma students on civil engineering subject, structural engineering, unit 4, RCC columns, it is lecture 2. And now we are going to see the design of short axially loaded columns, RCC columns, and with a worked out example. And the data given here is M20 grade and Fe 415 grade steel. Axial load on the column is 1400 kilonewton, and we are asked to design a short square column, and the key words are here short and square columns. Since it is given directly as short, no need to find out the slenderness ratio, and also the shape of the column is given. So, it is easy for us to find out the side of the column. Data given, axial load, remember the value is given as axial load. So, we have to find out the design axial load. Here it is given as axial load only. So, this is characteristic load, and we have to follow the limit state method, and concrete grade is M20 and the steel grade is Fe 415. First step is to write down the data given, and the second step is to find out the size of the column. So, அப்போ கேள்வி கேட்டிருக்கிறது ஆக்சியல் லோடு கொடுத்துருக்கு 1400 கிலோநியூட்டன் கொடுத்துருக்கு, என்ன காங்க்ரீட் போட போகிறோன்றதையும் கொடுத்துருக்கு, M20 கிரேட் காங்க்ரீட் கொடுத்துருக்கு, அண்ட் ஸ்டீல் என்ன கிரேட் யூஸ் பண்ணணும்னு சொல்லியிருக்கு. என்ன டிசைன் பண்ண போகிறோம் அப்படின்னு சொன்னால் ஷார்ட் ஸ்கொயர் காலத்தோட டிசைன். இப்போ டிசைன் அவுட்புட் என்னவா வரக்கூடும், இல்லை ஆன்சர் என்னவாக இருக்கும், டிசைனோட ஆன்சர் என்னவாக இருக்கும் அப்படி சொன்னால் சைஸ் ஆஃப் த காலம். இங்கே சைஸ் ஆஃப் த காலம் பொறுத்த வரைக்கும் ஸ்கொயர்னு கொடுத்ததுனால சைடு கண்டுபிடிச்சா போதும். சின்ஸ் இட் இஸ் கிவன் எ ஸ்கொயர் காலம், ஸோ யூ ஹாவ் டு ஃபைண்ட் அவுட் த சைட். இது ஃபர்ஸ்ட் ஆன்சராக இருக்கணும். டிசைன் அப்படி சொன்னால் இதுதான் அவுட்புட்டாக இருக்கணும். ஸோ அப்போ சைஸ் ஆஃப் த காலம் கொடுத்துருக்கணும் வரணும். செகண்ட் ஒன் ஏஎஸ்சி ஏஎஸ்னா ஏரியா ஆஃப் ஸ்டீல் இன் கம்ப்ரெஷன், ஆர் இன் அதர் வேர்ட்ஸ் த லாங்கிடியூட்னல் பார்ஸ் ஆர் மெயின் பார்ஸ்னு யூஸ்வலாக சொல்லுவோம் இல்லையா, அந்த மாதிரி லாங்கிடியூட்னல் பார்ஸ் ஆர் மெயின் பார்ஸ். அண்ட் இதில் ஞாபகம் வச்சுக்க வேண்டிய ரெண்டு விஷயம் என்னென்னு அப்படி சொன்னால் 12 mm ராடுக்கு மேற்பட்டு இருக்கணும், இல்லை 12 mm இருக்கணும் டயாமீட்டர், இது ஞாபகத்தில் இருக்கணும். ஸ்கொயர் ராட் ஸ்கொயர் காலம் ரெக்டாங்குலர் காலமாக இருந்தால் அப்போ குறைஞ்சபட்சம் 4 நம்பர் இருக்கணும் அப்படின்றது ஞாபகத்துக்கு வரணும். தென் தேர்ட் ஆன்சர் ஆர் தேர்ட் அவுட்புட் ஷுட் பி த லேட்ரல் டைஸ். லேட்ரல் டைஸில் டிசைனுக்கு எந்த வேலையும் இல்லை. ஃபாலோ த ப்ரொவிஷன்ஸ் given in the code book. So, find out the diameter of the bar and the pitch, and this should be expressed in terms of millimeter, and also this should be expressed in terms of millimeter, that is all. So, நம்ம டிசைன் அப்படி சொன்னால் இது 3 அவுட்புட் இருக்கணும். அப்போ இந்த 3 அவுட்புட் இருக்கணும் அப்படின்னு சொன்னால் டக்குன்னு அந்த ஸ்டெப்ஸ் ஞாபகத்துக்கு வரணும் நமக்கு. அண்ட் ஃபார்ச்சுனேட்டாக டிசைன் ஆஃப் ஷார்ட் ஆக்சியலி லோடட் காலமில் ஒரே ஒரு ஃபார்முலா தான் இருக்குது. என்ன ஃபார்முலா அது? PU is equal to 0.4 times of FCK into AC plus 0.67 FY ASC. இது ரொம்ப ஈஸி ஃபார்முலா டு ரிமெம்பர். இதை ஞாபகம் வச்சுக்கிறணும். ஸோ இந்த ஃபார்முலாலேருந்து தான் நம்ம வந்து கிராஸ் ஏரியாலாம் ஃபைண்ட் அவுட் பண்ண போகிறோம். கிராஸ் ஏரியாலேருந்து ஏரியா ஆஃப் ஸ்டீல் ஃபைண்ட் அவுட் பண்ண போகிறோம். அதுக்கப்புறம் கோடல் ப்ரொவிஷன்ஸ் என்ன சொல்லியிருக்கோ அதை செக் பண்ண போகிறோம். அவ்வளோதான், ரொம்ப சிம்பிள். சைஸ் ஆஃப் த காலம், செகண்ட் ஸ்டெப். Let the gross area of the column, A is missing here, area of the column be AG, assuming 1% of AG as longitudinal reinforcement. So, the minimum is 0.8% of AG to the maximum is 6% of AG, and for all our practical purposes it is restricted to 4% of AG. So, we can assume any value between 0.8% AG to 4% AG. But in general it is assumed as 1% AG to 2% AG. So, this we have to bear in our mind. And again 1% of AG is nothing but 1% of AG is equal to 1 divided by 100 of AG. So, this is equal to 0.01 AG. very simple to remember. So, area of steel is here, it is assumed as 1% of Ag, therefore, AAC is equal to 0.01 Ag, and area of concrete, again area of concrete is equal to, this is nothing but area of concrete is equal to gross area of the column minus area of steel in compression or the longitudinal bars, and this is Ag minus this is of course ASC. ASC is assumed as 0.01 Ag, and so from this 1 minus 0.01 will give you 0.99 Ag. So, this is the value of AC. Now, substituting all these two values in this expression, so 0.4 FCK AC plus 0.67 FY ASC, and PU of course arrived at, see this is 1400 is a characteristic load, and multiplied that by partial safety factor, this is nothing but the partial safety factor for load. So, the design load is found to be 2100 kilonewton, and this is equal to, we can rewrite this as 2100 into 10 power 3 Newton, because 1 kilonewton we all know that this is equal to 1000 Newton. So, converting kilonewton into Newton and substituting that, solving, gross area of the column is found to be 196,252.51 millimeter square, and this is the area of the gross area of the column. Now, we must know the formula to find the area of each shape. For square column, the area is equal to, if the side is A, we know that Ag is equal to A square, and for rectangular column, suppose if the breadth is B and the depth is D, Ag is equal to B into D, and for a circular column of diameter D, then the area of column is equal to pi d square by 4. So, all these three simple formulae one has to remember. Now, for in this case it is a square column and the area is found to be this value, and for the square of course the formula is A square. To find the side you have to take the square root of this one, therefore, this is square root of 196,252.51 is equal to 443 mm, and this cannot be used as such because it has to be rounded off for the practical application. So, 443 millimeters is rounded to 450 millimeter. And now the side of the column is arrived. So, the side of the column is 450 mm by 450 mm, and from the side of the column we have to find out the gross area of the column. So, gross area of the column is here, and we have initially assumed the gross area, I mean area of steel as 1% of gross area. So, this is equal to, that is ASC is equal to 0.01 into Ag, and remember, after the calculation of the gross area and after the finding of side of the square column, again you find out the gross area because you have rounded off. This is not 450 as per the calculation, this is only 443 millimeters, you have rounded off that to 450 mm. So, now you have to calculate the actual gross area of the column. So, 450 by 450 will give you the actual gross area of the column, and this is the percentage that you have assumed. So, area of steel in compression or the area of longitudinal reinforcement is found to be 2025 millimeter square, and you can assume the diameter of the bar from 12 mm. So, minimum diameter of the bar to be assumed is 12 mm, this we have to keep in our mind. So, in this case 20 mm diameter is assumed, and also 16 mm diameter bars also assumed. For the economical reason, we can have a combination of two diameter of bars. So, in this case we have assumed 20 mm bar as well as 16 mm bars, and providing 4 numbers of 20 mm bars and 4 numbers of 16 mm bars, the actual area of steel is found to be 2060 millimeter square. Then that means we have to work out that ASC, actual ASC is equal to 4 numbers of 20 mm bars, of course 20 square by 4 plus 4 numbers of 16 bar. So, 16 square by 4. So, this comes around 2060 millimeter square, but as per design it is 2025, which is greater than that, then this is okay. And this is about the longitudinal bars. As far as the lateral ties are concerned, we have to follow the procedure given or provisions given in the code book. So, the minimum diameter of the lateral tie is the greater of two conditions, 1/4 of the largest longitudinal bar. So, here the largest longitudinal bar is 20 mm. So, that comes as 5 millimeter, and the second condition is 6 millimeter. So, the greater of these two 5 and 6 is 6 millimeter. So, we have to use the diameter of the lateral tie as 6 millimeter, and the second one is the pitch of the lateral tie. In that, for that we have three conditions. One is least lateral dimension of the column and 16 times the smallest longitudinal bar and 300 mm. Here it is not, it is 450 mm, it is mistakenly typed here, it is 450. So, first condition is 450 mm and second condition is 256 mm and third condition is 300 mm. So, we will take the least one. So, the least one is 256 mm. So, if you round off that 250 mm. So, the result of the lateral tie is this in the form of diameter of the bar as well as the pitch we have to give. Then that means, in this case providing 6 mm diameter of bar at 250 mm pitch is the answer for the lateral tie. So, answer for this problem is the size of the column is found to be 450 millimeter by 450 millimeter, it is a square column, and longitudinal reinforcement 4 numbers of 20 mm bars and 4 numbers of 16 mm bars. Lateral ties 6 mm diameter bar at 250 mm pitch. And to visualize the design output, of course, all the design details will be given as a drawing output for the usage at the site. At the site, of course, the site supervisor or the site in charge or the site engineer, whoever it is, based on the detailed drawing given to him or her, they have to read the drawing and they have to execute the work accordingly. So, detailed drawing plays an important role. This should be depicted or this should be drawn from the design output, whatever may be the design output, and that is to be carried here or transferred here in a correct way. So, for this exercise, the size of the column here it is written as 450 by 450, that is first answer, and the second answer is main reinforcement bars and all the 4 corners 4 20 mm dia bars are placed, and at the midway 4 16 mm dia bars are placed, that is the second answer. And the third one, the lateral ties 6 mm dia is the lateral tie at 300 mm center to center, it is not 300 mm here, it is 250 mm. So, I will make a small correction here, it is 250. So, 6 mm dia at 250 mm center to center. So, this is the cross section of the short axially loaded column that we have designed now. And of course, as far as the lateral ties are concerned, code prescribes the distance, if the distance between the corner bars, the distance between this bar and this bar exceeds 48 times the diameter of lateral ties, the intermediate bars are also to be tied effectively in two directions. Then that means, if the distance between the corner bars exceeds 48 times the least diameter of the lateral tie, here it is 8 mm is the condition, and the distance between the corner bars, here the corner bars 450 minus cover on either side 40 into 2. So, this will give you 370 mm. Since this 370 exceeds the 48 times of lateral diameter, we have to connect or we have to tie the intermediate bars also in both the directions, and therefore, this additional tie is provided. This is the additional tie Though our result ends at this point, for the practical applications and to follow the codal provisions, we have to ensure this. So, in this case the answer is this: size of the column is 450 by 450 and the main reinforcement is 420 plus 416 mm bars, and the lateral tie is 6 mm dia 250 center to center or pitch, and again an additional tie tying the intermediate bars. And we will also see the second example. Again it is a design problem. Design a short RC column of, the only difference is here it is a rectangular column of size 300 mm by 450 mm, and the axial load given, again the axial load, it is not design load. So, it is a characteristic load only. So, axial load is 1000 kilonewton and grade of concrete given is M20 and steel is Fe415. We will quickly go through this one. RC column of size 300 by 450 mm, axial load, and therefore, from this point itself you have to remember that we have to find out the design load, this remember. And again for RC column of rectangular section, one has to remember the formula to find the area of a rectangular section, probably B into D. We can take this value as B and this value as D. So, this you have to remember and this again you have to remember. Now, the area of the column, since the area of the column is directly given, one need not assume the area of steel in terms of gross area of the column. That is, in the previous problem, area of steel is assumed as 1% of gross area of column, and the balance data are worked out, and substituting that we have found the size of column. But in this case you are given the size of column directly. So, there is no need to assume. So, remember this point also, no need to assume ASC, right. So, now area of concrete is equal to gross area of the column minus ASC. So, this is the area of concrete and design axial load on the column is 1.5 times, this is the partial safety factor and this is the design load. Again the same old formula, of course, this is the formula to be used. Strength, design strength of the column is Pu is equal to 0.4 FCKAC plus 0.67 FIAC. Substituting the relevant values, area of steel in compression or the area of longitudinal reinforcement is found to be 1555.27 millimeter square. Again now we have to find out the number of bars. So, before that you assume the diameter of the bar, it should be always greater than or equal to 12 mm. So, now assuming 16 mm bars, number of bars, of course, we can also calculate the number of bars required using this expression. Number of bars is equal to area of steel arrived divided by area of a single bar. So, in that case, in this case, this is 1555.27 divided by pi into 16 square by 4, since we have assumed 16 mm bars. So, this is the area of a single bar. So, number of bars probably it may be less than 8, probably it may be around 7.5 something. So, if you round off this one, you will get 8 numbers. This is the way you have to work out the number of bars. So, now providing 8 numbers of bars of 16 mm dia, the actual area of steel is provided is 1608 millimeter square, and this is as far as the main reinforcement is concerned. And the fifth step is to find the transverse reinforcement or the lateral ties. And again we have to follow the codal provisions. As far as the diameter of the lateral tie is concerned, there are two conditions. One is 1/4 of the dia of the largest longitudinal bar, that is 4 mm, and the second one is 6 mm, the greater one is 6 mm. So, provide the 6 mm diameter as a lateral tie, and maximum permitted pitch is the least of 3 conditions. One is the least lateral dimension, that is 300 mm, and 16 times the smallest longitudinal bar, that comes around 256 mm, and the third condition is 300 mm, and the lesser one is 256, which is approximated to 250 mm. So, the answer is provide 6 mm dia lateral ties at 250 mm center to center. Now, the answer part, size of the column, of course, it is given in the problem, and the area of steel or area of longitudinal reinforcement is found to be 8 numbers of 16 mm dia bar and lateral ties 6 mm dia bars at 250 millimeter center to center, and this is the of course detailed drawing. This is the breadth of the column 300 and this is 450. 8 numbers of 16 mm dia are provided like this in this manner, and the lateral tie 6 mm dia 250 mm center to center. Again the intermediate bars are not connected, but as per the codal provision this has to be connected. The intermediate bars are also to be connected by providing additional tie. So, this one has to remember. Again the same procedure is to be followed. Find out the distance between the corner bars. If that distance exceeds 48 times the diameter of the lateral tie, then we have to provide the lateral tie for the intermediate bars in both the directions. So, following that procedure and this additional tie is provided in the sketch. And we have seen in example 1 a square column, an example 2 a rectangular column, and in this case in this example we are going to design a circular column and which has to carry an axial load of 1000 kilonewton with circular rings or lateral ties. And as you all know that circular column will have two types of ties, one is the circular tie as well as helical tie. So, in this exercise we are going to design a circular column subjected to axial load with a circular tie, and concrete grade shear given as M20 and the steel is Fe 415. Axial load is 1000 kilonewton, data given of course, and the grade of concrete, grade of steel. And again here the size of the column is not given. Therefore, what you have to do is, since, or I can write here, since the size of the column is not given, assume the area of steel in compression. Again in general it ranges from 1% of Ag to 2% of Ag. So, in this case it is assumed as 1% of Ag. So, area of steel in compression is found to be 0.01 Ag, and area of concrete is deducting the area of steel. This is the area of steel part, area of steel from the gross area of the column, area of concrete is found, and substituting that in the formula, gross area of the column is found to be 140180.36 millimeter square. Since this is a circular column, area for a circle is pi d square by 4, equating this to this will get the diameter, and therefore, from this d is equal to the square root of 140180.36 divided by pi into 4. Now, so diameter of the column required is, of course, here it is there, and 422.47 millimeter, and which is to be rounded off to the nearest practicable value. So, here it is rounded to 450 millimeter, and the actual gross area of the column, again you substitute pi into 450 square by 4 is equal to 159043.13 millimeter square. And now, area of longitudinal reinforcement, it is 1% we have initially assumed, substitute the value, and area of steel in compression or area of longitudinal reinforcement is found to be 1590 millimeter square. And again assuming 16 mm bars, number of bars is equal to ASC divided by pi into 16 square by 4. So, this is equal to probably 7 point something, which is to be rounded off to near 8 numbers, 7.5 something rounded off to 8. So, that is how the area of steel in longitudinal reinforcement in terms of diameter of bar and number of bars is worked out, and the actual area is given here. And again transverse reinforcement as far as the lateral ties is concerned, again two conditions. The first condition is 4 millimeter and the second one is 6 millimeter, greater one is 6 mm, and pitch least lateral dimension is found to be here the diameter, since it is a circular column, the diameter is found to be 450 mm. So, only one dimension. So, 16 times the smallest longitudinal bar 256 and 250. So, the smallest value is 256, rounding of that you will get 250 mm. So, provide 6 mm diameter lateral circular bars at a pitch of 250 mm center to center. And of course, this is a detailed drawing showing the answer. Diameter of the column and the number of bars and the diameter of the area of longitudinal bar and the lateral tie. And this circular column with helical reinforcement, this is very important to note. Helical reinforcement, if you are given a problem with helical reinforcement, then the point to come into your mind is %5% increase in the strength. Then that means the formula is multiplied by 1.05. This you have to remember, helical reinforcement, this is very important. Now, helical reinforcement given and the axial load is given, grade of concrete, grade of steel is given, effective length of the column is given. Then that means you have to check one more parameter, namely the slenderness ratio. If the length is given, then you have to find out the other parameter, that is slenderness ratio as well as the eccentricity value. That is the clue. For the previous three problems, we have not checked the slenderness ratio or the minimum eccentricity value. For this problem, since you are given the effective length of the column as well as the effective length of the column, we have to check the slenderness ratio whether it belongs to short column or long column, and also we have to check the eccentricity for the column. And remember this helical ties. And now design load, which is to be multiplied, that is characteristic load multiplied by partial safety factor will give you the design load, and for this the design load is 1725 kilonewton. And since the size of the column is not given, assume the percentage of or area of steel in terms of percentage of gross area of column. So, it is here it is assumed as 1% of Ag. So, AAC is this, and area of concrete from deducting gross area, deducting area of steel from gross area. So, that is area of concrete. Substituting the relevant values, Ag is found to be this, and since it is a circular column, diameter is the dimension. So, diameter is found to be 453 rounded off to 470 mm. Now, the actual area of the column is found to be 173494.45 millimeter square, and we have to check this column for the slenderness limits or slenderness ratio. So, effective length is given as 3 meter, that is equal to 3000 millimeters, and diameter of the column is 470. So, slenderness ratio lambda is equal to L effective by D. Here it is not D or B, it is only diameter, and that gives you 6.38. Since this value is less than 12, the column is to be designed as a short column. This is very important. Suppose if it exceeds 12, then it is to be designed as a long column. Which one? The lambda exceeds 12, then this is to be designed as a long column. And again you have to check for the minimum eccentricity. As per the codal provision, the minimum eccentricity value is L by 500 plus D by 30, and here it comes around 21.67 millimeters. The minimum eccentricity value, this is the actual eccentricity, this is the actual eccentricity. The minimum given by the code is 20 mm. The maximum permitted eccentricity on short column is 0.05 D, that is 23.5 mm. Since the actual eccentricity, even though it exceeds the minimum eccentricity, which is found to be less than the maximum permitted eccentricity, and therefore, the minimum eccentricity may be ignored. The column is assumed as or to be taken as a short axially loaded column. This is very important, axially loaded column, and accordingly, of course, we have checked the slenderness ratio as well as the eccentricity limits. Now, the reinforcement details. Longitudinal reinforcement, it is assumed initially 1% of gross area, that comes around 1734. So, providing 16 mm bars of 9 numbers, the actual area of steel is found to be 1809 millimeter square. And again, transverse reinforcement, remember this is helical tie, we have to follow the same codal provision as far as the diameter is concerned. So, since it is not given here, or I have assumed the diameter of the bars as 8 mm. But students, what you have to do is you have to write the provisions given in the code for the diameter of the lateral tie. The first condition for the diameter of lateral tie is 1/4 of the die is the greatest of or greater of largest longitudinal bar, and second condition is 6 mm. So, for this case it works out to be 1/4 of largest longitudinal bar here 16. So, this is only 4 mm and this is 6 mm. So, largest is greater is 6 mm. Even though as per the codal provision the diameter of the lateral tie is 6 mm, assumed here it has 8 mm, and accordingly the other parameters are worked out. The maximum permitted pitch is the lesser of 75, and all these are given in the code. So, maximum permitted pitch is the lesser of 75 mm or 1/6 of the core diameter. Here the core diameter is 406 millimeter. So, 1/6 is 67.67. So, the lesser value among these two 75 mm and 67 is 67. So, keep that value, and minimum permitted pitch is the greater of these two 25 mm and 3 times of the helical reinforcement diameter, which is 24 mm, the greater is 25 mm again. So, the pitch is to be provided between pitch of the helical tie, here to be provided between 25 mm to 67 mm. So, 25 mm is the minimum and 67 mm is the maximum. The remaining portion, that is a check for the helical tie reinforcement pitch, we will see in the next lecture. Thank you for watching this video.